So now actually we have opened up. Statcraft. This is the opening screen of Statcraft. Now I will be using this tool for doing on Likert scale hypothesis testing. And what is the Likert scale? It is a scale of 1 to 5. In the previous tutorial, we actually had done hypothesis testing of T and Anova parametric, non-parametric test for a university grade school. So there was no Likert scale testing there. Likert scale survey was not there. In this case, there will be a Likert scale survey. Usually, most of the research is done on Likert scale, where you take a opinion and convert that into a scale of 1 to 5. 1 being lowest, 5 being highest, and vice versa also. It doesn't make any difference because this is an ordinal scale. Ordinal scale is a rank scale. So there is a lot of the controversy of whether it should be a parametric test or non-parametric test, because scale used is ordinal. You are ranking the data, but we are using this for parametric for most of the hypothesis. And what decides the parametric or non-parametric test is the test of normality. Now, let me first see the data. What exactly is the data? Okay. Let me see the data. I'm first opening the Likert survey hypothesis data. This data is a very common database. It is basically a bank which has got several services, which is locker facilities, demand draft, fixed deposit, accounts, ATM, loans, and cash. And it is basically it has taken a survey of around 100 people and to check the quality of these services. And the grouping variable is the income levels. So you can see the metadata. The income levels is called earners. Earners are people who are making less than 200,000. Lower middle class is 200,000 to 500. Upper middle class is 500,000 to 1 million, which is more than 1 million. These are all in dollars. This is a US case study. So there are 4 levels of income levels which are there. So if we are doing any hypothesis testing, and if this is basically the grouping variable, then you know that it is 4 groups. So we will be doing an Anova test. So it is also very clear that there will be 2 types of hypothesis. The number 1 hypothesis is null hypothesis, which is the all services are similar as far as the various income levels are concerned. The alternative hypothesis HA is at least one of the services is significantly different for different income level people. All services are not similar based on the income level. Services are 1, 2, 3, 4, 5, 6, 7. Locker facilities, demand of fixed deposit accounts, ATM, loans, and cash. Now, this is the metadata. Earning levels, 4 levels is the grouping variable, and the rest 7 are the testing variables. And since we are taking a Likert survey, we have taken highly satisfied as 5 and highly dissatisfied as 1, neutral as 3. But if you just reverse the rating, that is, you take highly satisfied as 1 and highly dissatisfied as 5, the overall hypothesis results will not change at all. Now, based on that, you do something which is called customer rating for services. This is the output of the survey. And as you can see, 100 people have been surveyed. And the first is obviously ask them the grouping variable question, what is your income level? So they will take mark one of the 4 categories of income level. So there are 4 categories of the income level. And again, the income levels I will show you: earners, lower middle class, upper middle class, and rich. So it is going to be more than 2 groups, 4 groups. So it's going to be a Anova group family test. Then there are basically the testing variables, which are basically the number variables. Testing variable results are coming in Likert scale, which is a rank data scale, ordinal scale. So on a scale of 1 to 5, for example, the respondent number first, which is coming in serial number 2, because first is a header, his income level is 2, which is basically your income level 2 is 200,000 to 500,000 dollars. He has rated 1 for ATM. What is ATM? 1 means highly satisfied. Similarly, locker facility is 4. Fixed deposit is 4. Loans he has rated 5. Loan service is highly satisfied. Highly satisfied is 5. So he is highly dissatisfied with ATM and highly satisfied with loan and accounts. And he is overall satisfied with cash, fixed deposit, is neutral under demand draft. And then you add all this 1 to 5 scores of this 7 locker service questions, and the total will be 26. So income level 2, total is 26. Now this 26 can be treated as a ratio variable, whereas I am treating the rest as ordinal variables, rank variables, but this total I treat as a ratio variable. So how this total is coming? It is very simple. You ask one grouping variable question. Please tick mark your income level 1, 2, 3, 4. Mention the 4 levels. Tick mark one of them. Then you start questioning the put 7 questions. Like first question is on a scale of 1 to 5. 1 is highly dissatisfied and 5 is highly satisfied. How do you treat ATM? Please take. So he takes one of them. Then you go to locker facility, cash account, and then you simply total up all these marks. Similarly, respondent number 18, which is coming on serial number 19, his income level is 4, which is rich, and he is marked ATM as 1, highly dissatisfied, and he is not marked highly satisfied in any of the other 7 questions. Overall, he is satisfied with fixed deposit and loans, and his total score is 19. So this is how you actually do a Likert scale survey, and obviously you send it on WhatsApp, the questionnaire on Google Forms. People simply fill up by ticking. It's all questions are tick mark. There is no subjective. That's why it's a quantitative survey. And then based on that, since the sample size is 100, and you want to make a estimate, you want to estimate the parameters of the entire population, that is all the subscribers of this bank, you are doing a hypothesis testing. Hypothesis testing always gives you results of the population based on the findings of the survey. Survey is a sample. So sample can be easily tested. Now, whatever you get the mean and standard deviation in the sample, these are only descriptive statistics. They are only about the sample. They do not infer anything about the population because it could be a chance sample. Though it is a randomly distributed chosen sample, so it still can be a chance sample. So that's why the relevance of the t-test and the p-value. The p-value is the most important. Now, having seen this data, and you can do the same thing on SPSS, you come to Statcraft, just a tool that I'm using, obviously. So I will just import this data, name some data. I'm just giving it some name, and then I simply go to my folder and I import this data. When I import this data, you can see that every tool will have its own way of renaming the variable. So it doesn't allow any space between any two variables. So that's why everything, whatever is given in red means it's not allowed. And that's why this OK button is not active. So just reduce this and remove this space. Then it becomes black. Similarly, I'll reduce this space. I'll reduce this space. Now this actually gives you the metadata. The metadata gives you the measure. Now this is what is the beauty of tools like SPSS and Statcraft. It simply gives you the metadata. Otherwise, had it been in Excel, I'll tell you what are the difference in Excel and this. You have to actually convert metadata out of the raw data. So the first thing that you have seen in SPSS and also the same in Statcraft, it gives you a one-click button to convert from the raw data, extract the metadata. Metadata is basically you simply segregate the various variables and mention what are the scales of measurement. Now, in this case, annual income is showing as a scale. So it is not a scale, it is a nominal variable. So I will change it because it is 1, 2, 3, 4. It is a category, so it is a nominal variable. Now, the rest of the things, like I can see ATM. ATM is a scale of 1 to 4, 1 to 5, highly satisfied to highly dissatisfied. So I'll change it into ordinal. Locker facility, again, ordinal. These are all questions regarding the Likert survey questions of 1 to 5, which is a rank variable or ordinal scale. Fixed deposit is also ordinal. I'm changing the scales here, which is not possible in Excel. I have to do that manually. Loans also is ordinal. I think same thing is what you do in SPSS, exactly the same thing. Ordinal, change it again to ordinal. Cash, ordinal. Now total, which is the sum total of all these things, is not ordinal. That is scale. So I somewhere you rank 1, somewhere 2, somewhere 3, 4, 5. I total all the 7 questions. The maximum will be 35. The minimum will be 7. So the score will be anything between 7 to 35 per respondent. And that will be the scale variable. Now, I've actually done the meta data, which is basically changed measures of the measures of scales of measurement. Only the annual income, which is basically a grouping variable. Grouping variable in t-test and Anova test is always a nominal variable. Based on that only, we are testing the variables. So there's a grouping variable and there's a testing variable. The grouping variable is nominal. The rest of the variables could be ordinal, interval, or ratio. And the testing variable in this case is total, which is scale variable. So I will just press OK. So what am I going to test here? I am going to test that null and alternate hypothesis based on the testing scores. Testing scores is total. And my grouping variable is 1, 2, 3, 4 in the annual income. Null hypothesis says there is all services are similar across all income groups. Null hypothesis. Alternate hypothesis is at least one of the services is significantly different across all income groups. So it's fine. Now I can go for the test. So as you know that before I start any test, I first of all go, and in fact, the test that I'm doing is only 2. Only at Anova test because the number of group size is 4. The grouping variable is annual income and the testing variable is total. So I will go to first of all check the normality of the data because obviously the normality of the data will tell me whether to go for a parametric test or non-parametric test. So I will go for Shapiro-Wilk test, normality of the data. And the variable that I choose here is a numerical variable or a continuous variable. It's a univariate variable because I'm checking the distribution of this data. And this will be total, a testing variable. I'm checking the normality of this testing variable total. And as you can see, the Shapiro-Wilk test gives me a p-value of 0.0002 on a 95% confidence interval. Null is rejected because p-value is less than 0.05. So the null is rejected and alternate hypothesis is accepted. So we don't never say alternate hypothesis accepted. We only say fail to accept null and reject null. Here we are rejected null because p-value is less than 0.05. Because the threshold value is 0.05 at 95% confidence level. Now, what does it mean that the data is null? What is the Shapiro-Wilk test null hypothesis? Null hypothesis, data is normally distributed. Alternate hypothesis says data is not normally distributed. If p-value is less than 0.05, data is not normally distributed. If data is not normally distributed, I go for non-parametric test. I know that I have to go for Anova because it's more than 2 groups, and I go for non-parametric Anova test. I go to this compare groups. But if I see the parametric test, there is a one-way Anova, two-way Anova, but I'm going to non-parametric test. So I'll go for something which is called a crucial Wallis test. Non-parametric Anova test is crucial Wallis test. We'll go to crucial Wallis test, and on the variable side, I will simply pick total. On the factor side, which is the grouping variable, I will pick up the annual income, 4 annual incomes, and the total source. Okay. So what is the p-value here? The p-value is 0.00322. Clearly, the p-value is less than 0.05. What is my null hypothesis? All the 7 services of banks are similar across all income groups. What is my alternate hypothesis? At least one of the services is significantly different across the income groups. So it is alternate hypothesis, which is true. Null is rejected because P is less than 0.05, which actually means that when you have 4 income groups, at least one of the services is perceived to be different across the income group. That means it may happen that the bank may be giving a different service to the rich guys and lesser to the poor guys, or it maybe sometimes in cooperative banks it may be vice versa. But it is felt that all services are not similar when it comes to income level of the users of the bank. Because P is less than 0.05, null is rejected. Null means all services are similar across income groups. Alternate says that it is not similar across income groups. Now, I will do the same thing. It was a very simple test done very quickly. I will do the same thing in Excel, but Excel doesn't give me the privilege of doing a non-parametric test. So I will use the same thing, assume the data is normal, so that I can compare the results. Let me do one-way ANOVA because it is a one-way ANOVA. There is no interaction between the groups here. Now I am assuming the data is normal, that is the total score is normally distributed. So the variable I'll be using is total again, and the factor that I will be using is annual income. And I will say OK. P-value is 0.00203. The P-value is not similar, but in both the cases it is less than 0.05. So whether I go for a normally distributed, assume that data is normally distributed, or I assume that it is not normally distributed, I do parametric test ANOVA, I do a non-parametric ANOVA test, which is a crucial value test. Both the cases, null hypothesis is rejected because p-value is 0.05, less than 0.05. Now, this is as far as Statcraft is concerned. Now, let me go to this Excel sheet and do the same thing here. Now, when you look at the Excel sheet here, I want to do the same thing on the Excel. So obviously, you have something called data analysis. The plugin has to be there. Now, these are the scores of the respondents, and this is the metadata. But I have to find out, I have to segregate the data, the total scores as far as the incomes are concerned. That means I have to find out all the income levels of one and what are the total number of respondents and their corresponding scores. Similarly, in income level 2, 3, and 4. That part has to be done through Excel formulas. It can't be done automatically like it is done in SPSS or Statcraft. So let me show you an Excel sheet where I have actually already done it before. And when you do this, this is how you get it. Now, if you see this income slabs, I've already done this through Excel formulas. So you can do it manually also. So there are 4 income levels: earner, lower income, upper income, and rich. And total number of 17 respondents are there in earners, and these are their total scores. Like respondent number 2, who is coming in earner, his total score is 27. Similarly, the total number of respondents in the next group, which is the upper middle class, is 38, 37. Then after that, it is the total number of respondents is 39. And in the rich, there are only 7 respondents. And the total scores of each of these respondents are there. So what we have done here, we have actually segregated earners, low middle income, upper middle income, and rich into 4 categories, and then seen what are the total scores of respondents who are earners, who are low middle, upper middle, and who are rich. When you add up all this thing, total will 100 respondents. The sample size is not similar. What I do, the null hypothesis is exactly similar. Unless customers, all categories of income have similar perceived value of services of all the category services of bank. Alternate hypothesis, customers of different categories, that is different income level, don't have similar perceived values of the services of the bank. Now I will go to the data tab here, to data analysis. There is nothing called parametric, non-parametric test. So I assume that this is a parametric test because data is normal. I will do single factor Anova. I will take the input range as everything. The 4 categories data and their score. These are grouped by columns, so I'll tick mark column. I have picked up labels. I have included labels, so I'll tick mark yes, so they are not counted. Alpha is 0.05, confidence interval is 95%. Take the output in a new worksheet. Okay. And this is the result. So I will straight away put the p-value. I'm not looking at the summary statistics. And you look at the p-value, it's 0.002. It gives you exact 0.00203. It gives you exactly the same results as Statcraft. You will get exactly the same results in SPSS and exactly the same results in Python or R, which actually is the same analysis. Alternate hypothesis is correct. Null is rejected. The perceived services of the bank is not similar across the income levels. So the answer, the results will be the same, whatever tool you use.
I don't think so.
Yeah, okay. The data is good. The data has been.
I have imported the data.
Data has been imported correctly. Just one second. Just don't do anything. Let me just see. Okay. The data has been imported correctly, and where do you get the scales of measurement?
These are scales of measurement.
Scales of measurement. Wait a minute. You've taken the 7 things as ordinal. Of course, V1, V2, V2 we don't need right now, and the annual is nominal, and the total you have taken correct scale. Fine. Okay. Fine.
I have to click here. Normality blocks tests. So now, so it is giving the 2 tests.
No, just go down on the QQ test. Kolmogorov is okay because for our sample you can take that. So even on the Q quantile plots, you can see that the observations are coming outside the line, so it's not a normal data.
Yes,
all the data should come on the same line.
Yes, sir.
So,
And
but you have shown that conglomerate of test.
Yes, sir. According to this also, sir, this is
the significance value is 0.012.
Yeah, which is less than 0.05. So we will reject the null.
So the conglomerate, no, it is giving both the tests. It is also giving you a Shapiro-Wilk test here. This is the significant value, which is the p-value is 0.000. So you have to reject the null hypothesis. That means the data is not normal.
Yes.
And then we do the crucial values test.
Yeah, now we go for non-parametric. So then
Analyze
independent
non-parametric independent sample.
yields.
Yield is total and group is annual income.
तो सर अगर हम इसमें I use customized test, अगर I use automatic, so we will use automatic best test.
Yeah, because the Man-Whitney U test is for independent sample T test. Man-Whitney U test is not there in Statcraft.
Okay.
To do the crucial values test for Anova. Run.
So this is coming. So null hypothesis is the distribution of total same across categories of annual income.
You get the same result, which is 0.003 as P value. Null is rejected. So the same results are coming in SPSS. So we have seen 3 tests here, 3 different tools. We have seen Excel, we have seen Statcraft, and we have seen SPSS, and the results are exactly the same in all these 3. Yes. Null is rejected. Null is rejected for Shapiro test, which is data is not normal. Null is rejected for our actual hypothesis test. That means the perceived level of service is different for different income levels.